Hi, I'm Gos, I'm 50 years old. In this lesson on the techniques and applications of definite integration, we'll take a look at this example here, where we're supposed to determine the volume of the region formed by the intersection of two cylinders, x squared plus y squared is equal to 4 and x squared plus z squared is equal to 4. So both of these, you already know, they are cylinders. And in fact, they're identical cylinders with a radius of 2. It's just that x squared plus y squared is equal to 4 is a cylinder extending in the z-axis, while x squared plus z squared is equal to 4 is a cylinder extending in the y-axis. So you just have this volume bounded within these two cylinders that you're supposed to find. Right, so there are a few different methods to find this volume here. So let's start with method 1. Well, in method 1, we are going to start with, let's say, a double integration. Well, how exactly do you know it is a double integration? Now, you can choose to put either y or z inside here. It's just that both of them, whether you use the first equation or the second equation, they will both become square root 4 minus x squared. But you might be slightly confused. How do we get all of these? Right, so first of all, you have this volume. And this volume, it is pretty much symmetrical around this origin. And by symmetrical around the origin, I mean in the first octant, in the second octant, third, fourth, fifth, seventh, and eighth octant, all their volumes are actually the same. So you just need to look at the first octant, then multiply by 8. So within your first octant, what are you going to have? Now let's say the first octant, we're just going to use the x and y. So a dx and a dy. So x, since it's the first octant, the range will be from 0 to square root 4 minus y squared. While for y, since it is the first octant, it will just be from 0 to 2, alright? So this will be the integration that we will have to solve. Alright, so let's take a look at how we can solve this integration. So first of all, you can choose to let x be something. And by this something, I do mean x being equal to 2, well, you can choose to use either sine or cosine x, alright? So let x be 2, let's say we use sine theta, since we will need to use a different variable. So if we let x be equal to 2 sine theta, we're going to have dx is equal to 2 cosine theta d theta. Now, we also need the range for theta, which will be from 0 to inverse sine square root 4 minus y squared over 2. Alright, so this is a substitution that you will have to make. So in this substitution, let's take a look at what happens. Since you have a 2 from here and a 2 from within this dx, that means you have 32. Then integrate from 0 to 2, and inside here you will have to change, which will have 0 to inverse sine square root 4 minus y squared over 2. Alright. Now, square root 4 minus x squared. So we already took the 4 from inside to outside. Then you just have 1 minus sine square theta, which is cosine theta. But since you have another cosine theta from behind, you just have a cosine square theta d theta. Alright? So this is what you will be seeing. And now, cosine square theta d theta and then dy. What you will have next is a use of your double angle formula. So from 32, it will become 16. Then integrate from 0 to 2. Then integrate from 0 to inverse sine square root 4 minus y square over 2. So this becomes 1 plus cosine 2 theta d theta dy. Right, so this is what you will have. Now with these parts, then you can integrate them. So you will have 16 integrate from 0 to 2. Now the first term you have is theta. Well, the second term we're going to have is half sine 2 theta. Then substitute in the boundaries of 0 to inverse sine square root 4 minus y square, and then over 2. And here dy. Alright, so how are we going to continue from here? Well, of course, we are going to substitute in your boundaries. But just be aware this half sine 2 theta will actually become a sine theta cosine theta. Well, why do we exactly have to put it like this? That's because later on, when you try to integrate them once again, what you will have is you need to substitute this value within. Since 0, no matter which one I substitute in, they're both 0, so you basically don't have those terms. Now if you substitute this inverse sine square root 4 minus y squared over 2 into the sine theta, and that will basically just be, so sine inverse sine square root 4 minus y squared over 2. This will just be a square root 4 minus y squared over 2. Since you might have already learned about sine and inverse sine, they are inverse functions. So when you have both of them together, you could just cancel them out. But wait, how about for cosine, then inverse sine inside? So in this case, you will actually have to draw the triangle for this. And by a triangle, so sine, we take a look at it. Now sine, you have the opposite over the hypotenuse. Then by Pythagoras theorem, you can find the adjacent. And since cosine is adjacent over hypotenuse, you can easily find it. So that means half sine 2 theta, it will become, and when you substitute in this boundary, you have a square root 4 minus y squared over 2 multiplied by y over 2. Alright? So here you have to add square root 4 minus y squared over 2, then y over 2. And here dy. Right. So this will be what you have to integrate next. So the second part, it should be relatively simple since you can put the y inside the dy. But for the first part, you're going to have to use integral by parts. So integral by parts, what are you going to have? So 16y inverse sine square root 4 minus y squared over 2. And you have to substitute in 0 and 2. Then minus 16 integrate from 0 to 2 y d inverse sine square root 4 minus y squared over 2. And here you have to add. So 16 divided by 4 and then divided by another 2. And you need another negative, which will have a negative 2 integrate from 0 to 2, then square root 4 minus y squared. And then behind, you're going to have d 4 minus y squared. Alright, so it seems like this is what you are going to have. Now, let's proceed. So, for the first term, you substitute in a 2. You have 2 multiplied by inverse sine 0, which is 0. Then you substitute in 0, which is 0 multiplied by inverse sine 1. So that will also be a 0. So the first term here is essentially a 0. Or next, you can just take a look at the second term you'll be having. Now in the second term, you have to bring whatever's inside your d outside, which is going to give you, so first it is a negative 16, then you have integrate from 0 to 2, y. So, inverse sine square root 4 minus y squared over 2. When you differentiate this, you will have a few different parts since you will have a chain rule of it. So firstly, differentiate the inverse sine, which is 1 over square root 1 minus whatever's inside squared. And whatever's inside is 4 minus y squared over 4, which then you just have y over 2, or y squared over 4, which then you square root to make y over 2, so you just have 2 over y. And next, you differentiate whatever is inside here, but of course once again, chain rule, you have this half, and then this square root, you're going to have square root 4 minus y squared, and then a negative y. Alright, so is this correct so far? Since the 2y and the half will just cancel out, so you can make it into this form, and then dy. Right, so for the part behind, you're just going to have negative, so what are you going to see here? You are going to have 2 multiplied by 2 over 3, which is 4 over 3 square root 4 minus y squared cubed, substituting values of 0 and 2. So we take a look at the first integration once again. We will realize 2 of these y's can cancel out, 2 of these 2's can cancel out. Then you're just going to have 16 integrate from 0 to 2 y dy, and then over square root 4 minus y squared. And then here you have to subtract, so when substitute in 2, you're going to have 0. When substitute in 0, you have an actual negative, and you're going to have 8, which is 30, which creates 32 over 3. Alright? So lastly, we'll just have to integrate the first part, where you have negative 8 integrate from 0 to 2 d 4 minus y squared over square root 4 minus y squared plus 32 over 3. Then of course you can solve this integration where you will just have a half, so negative 16 square root 4 minus y squared, substituting the values of 0 to 2, and then you add 32 over 3. Alright, so when substituting 2, it once again becomes 0, and then you substitute in 0, which will have a negative and a 32. So 32 plus 32 over 3, which will have 128 over 3, which should be your final answer. Alright, so this 128 over 3 will be the volume formed by the intersection of these two cylinders. But you take a look at this method, you integrate it with respect to x first. So what if you integrate it with respect to y first? And that will be our second method. So in this second method, what you will have is 8 integrate from 0 to 2, integrate from 0 to, instead of square root 4 minus y squared, this time you have 4 minus x squared. So then you have square root 4 minus x squared, then dy dx. So when you integrate with respect to y, you will take all the terms of x as constants, which means you're going to have 8 integrate from 0 to 2, 4 minus x squared, then dx, which from here you could just pretty much directly integrate already, where you have 32x minus 8 over 3x cubed. Substitute in the values for both of these as 0, 2, 2. Alright, so that means you're going to have 64 minus 64 over 3, which is also 128 over 3. So actually you'll realize if you integrate with respect to y, the method is a lot more simpler. And although both of these you can get the same answer, when you integrate with respect to x, when you integrate with respect to y, you might want to choose carefully on which one would actually look simpler. So these two methods are both for Cartesian coordinates. And I hope that you're clear of both of them so far. So I will be ending this lesson here, and thank you for your watching.